The Boeing 747 is a gigantic aircraft with an impressive capacity to carry literally hundreds of people together with all of their luggage. When you see such a mammoth beast somehow make its way elegantly through the skies in spite of its staggering size and weight, many questions typically cross your mind. How does it fly? How does it accelerate so fast? How was it even built in the first place? In today's video, we will be exploring the last question. How was the Boeing 747 built? To answer this fascinating question, we will have to take a brief trip down memory lane to see what life was like for this jumbo jet before it became the rock star we know and love. And then, from there, we will land on how these vehicles are assembled now. In case you didn't know where the term jumbo jet came from, the Boeing 747 is a plane to credit. The lead engineer on the development of the Boeing 747 was actually at work making a smaller 737 when the demand for air travel suddenly started to increase. In response, Joe Sutter abandoned the smaller project he was working on and took up the challenge of crafting the massive feat of engineering that would come to be known as the Boeing 747. Constructing the Boeing 747 was unlike anything the world had ever seen. The 747 was to come with a wide body and long range. It would then go on to become the first airliner with twin aisles in a standard 343 configuration. On the 30th of September 1968, the 747 rolled out of the Boeing's custom-built plant in Everett for the very first time. And a few months later, on the 9th of February 1969, the aircraft took its first flight. Shortly after, Pan American World Airways would place a large order for 25 747-100 variants. The 747-100 variant was the very first iteration of the Boeing 747, by the way. The model entered service on the 22nd of January 1970, and since then, all kinds of iterations of the 747 have been designed, resulting in the latest 747-8 model, which we all know today. The number 8 is derived from the 787, which gave the engineers working on the 747-8 the inspiration to go green with the 747. Thanks to the Gen X engines from General Electric, the 747-8 is the most efficient 747 Boeing ever produced. The 747-8 is made from stronger yet lighter materials, and so it is able to attain a range of 8,000 nautical miles in transit. On the ground, this translates to about 9,200 miles. This is a far cry from the 5,300 nautical mile range the older 747-100 model was able to achieve. If you think that building this aircraft would be an engineering nightmare, then you're absolutely right. Crafting a 747 is so grueling and complicated that since the 1960s, about 60-something years now, only 1,500 of these jumbo jets have been built. But then again, this is a plane we're talking about here. You certainly cannot compare what it takes to build a plane to what it takes to build a car, and so their manufacturing rates cannot be compared either. When it comes to the manufacturing of the 747-8, timing is of the utmost essence. All pre-manufactured parts must arrive at precisely the right time, so the workers can begin the crucial job of assembling them together. At the Boeing assembly plant, there are 3 shifts on each working day, and each shift could have even up to 10,000 employees working at the same time. When Boeing had to decide where to build its largest ever factory, it listed about 50 cities for consideration. Eventually, after much consideration, the company decided to go with Everett, which is about a half-hour away from Seattle. Construction of what would go on to be the largest building on Earth by volume began immediately. While that was going on, the assembly of the first ever 747 was also happening simultaneously. After the factory was completed, the resulting cavernous building stood at over 13.3 million cubic meters in volume. To give you an idea, imagine an Olympic-sized swimming pool. Now imagine there were 5,300 of those gathered together side by side in one place. That's how large 13.3 million cubic meters is. In height, the Boeing assembly plant is roughly the same as an 11-story building, and people have said that clouds form inside the building. Is that true or not? Well, we can't say, but what we can say is that there is a complex network of roads and pedestrian crossings within this gargantuan building, and workers typically get around the building by bike. There's a fire service always on standby as well, with high-street cafes that serve snacks and refreshments just in case some workers forget to pack their lunches. Something we assume must happen all the time when working in such an environment. This building is so gigantic and complicated, workers typically need months to fully become familiar with the layout of the assembly. We're looking at a complex with many different chambers, each one dedicated to the assembly of each model in Boeing's fleet. Usually when companies order one of these jumbo jets, they specify one with 366 passenger seats split across the primary deck. There would also be this partial upper deck as well, that would extend for a part of the plane's length, but which would then be sent back from the cone so companies can use a jet as a freighter plane with a large cargo door already added to the front end of the plane. Of course, implementing this huge door would be specifically handled by a dedicated team of workers from Boeing. Being the forward-thinking company that it is, Boeing believes its 747 would soon take center stage in cargo transportation. It also predicted that supersonic transport would overtake the use of regular airplanes in the transportation of people. What this would mean is that planes would now exceed 768 miles per hour. Now, while this would be an impressive achievement, it is yet to happen in the world of air travel awaits, with bated breath. Anyway, the partial upper deck we just talked about is why all 747s have a distinctive hump, a marker which many of us use to recognize a jumbo jet immediately. Today, the making of a 747 is pretty much a multinational experience. Seats come in from Germany, wing elements in from China, while wing flaps arrive from Australia. Once all the parts arrive at the assembly in Everett, all hands are on deck. And when we say hands, we mean human hands, because not a thing is automated in assembly and finishing of a jumbo jet. Everything is done entirely by hand. By this, Boeing stands behind its planes with a 100% guarantee. The company has taken painstaking steps to ensure that a 747 is always 100% safe for its entire lifetime on air. For instance, the wings come with literally thousands of fastening bolts, and each of them are double-checked by hand, not by robots, for greater assurance. Speaking of the wings, the 747-8 has the largest wings ever built by Boeing, and it is very important that each of them are meticulously built because each one will be holding about 58 tons of fuel. 58 tons of fuel will fill more than 1,000 cars up, and that's what each wing is supposed to carry. You might think that's a whole lot of fuel, and that is. But then again, the plane does burn about 10 tons of that abundant supply of fuel per hour at cruising speed. As you can probably tell, assembling the wings is an assiduous task. In fact, more than a quarter of the entire floor space at the Boeing plant is specifically dedicated to that task. This is because the 747 is not like any plane that either Boeing or other plane manufacturers have ever built. In its early days, the wings on a 747 swept in a backward direction at 37.5 degrees. Thanks to this ability, the plane was able to reach an efficient cruise speed of Mach 0.85, which translates to about 560 miles per hour. It also helped to reduce the overall wingspan of the plane, so it could still fit into the same hangars that used to accommodate much smaller planes. It was a clever idea proposed by the design team, although the construction work wasn't always as easy as it sounds on paper. The 747 jigsaw consists of 3 gigantic pieces: the rear end of the fuselage, the midsection, and the nose end. These parts are pieced together to form the body of the plane. The process is specifically carried out in wee hours of morning precisely for the reason that the process requires a few people in the way as possible. After putting the body together, the next challenge would be to install the engines. The engines used for the 747 are from General Electric, and they are the company's quietest ones yet. Precision during installation is very important as these engines are delicate. Each one weighs about 7 tons and is super expensive, costing about $20 million each. This makes it the most expensive piece of gear in the entire plane. Now, to ensure that the aircraft is sturdy enough to handle such heavy gear after installation, Boeing conducts some kind of structural test on each wing. So before the engines arrive, the workers on site hang some oversized concrete blocks from each wing, so as to mimic the weight of the engines. Only when the wings pass the test will the engines then be fitted into them. If you thought that was painstaking, then check this out. There are about 130 miles of wiring that go into the assembly of each wing. A dedicated team of workers has to check each of these cables one after the other to confirm that they are carrying enough juice. Juice that's sufficient enough to power roughly 50 households. And now to the aesthetics. Once the body and the wings have been pierced together, it's time to doll the plane up to give it some distinctive and personal look. The painting is done entirely by hand, again, no robots. At first, there's an initial base coat sprayed, after which another coat is in the carrier's colors is then applied. There's no use pointing out that the spray painting of a 747 is a long process, and this is a process that has to be repeated periodically, every 4 years to be precise. The amount of paint used has to be just right too, so there's a lot of calculation that goes into deciding on the amount of paint, because it has to be enough for the colors to remain bright for long, but not too thick that the engineers are unable to pick on vital corrosion signs early enough. Altogether, it takes about half a ton of paint to paint a 747 to standard. Assembling a 747 takes several months to plan, but less than 2 months to execute. After the finished project emerges, the plane then has to pass a series of stress tests before it's declared fit to fly. These tests are really extreme and exhaustive because the aim is for the 747 to surpass safety requirements. Some of these tests are even super radical, like pulling 2G mid-flight. During the test, experienced staff board the plane and buckle down tightly. Even their laptops and research equipment have to be buckled in as well. After that, they try to stimulate the different possible weight distributions the plane might experience by pumping water between a series of barrels. Flutter tests are then carried out in the air to prove the rigidity and airborne stability of the plane. And as for the plane's structural stability, this is tested by a slow takeoff during which the tail is dragged against the runway really slowly. Of course, this creates huge friction and will be well if the tail survives it without a scratch. But if the friction causes a hole to develop in the body of the plane, then it's all over. That plane has failed the test. Now, according to one of the engineers over at Boeing, if the hydraulic system that's supposed to raise the wing flap fails, the pneumatic system takes over. If the pneumatic system also fails, then the electric system takes over. All these are simple checks and balances, systems built into the plane to guarantee travelers 100% rest of mind. So, when you next board a flight on a 747, remember that you can rest assured in the fact that there's an almost 0% chance of anything wrong happening mid-flight. Why? Every part, every system, every process, the whole works have been checked and double-checked by humans. The 747 you see is a product of hundreds and hundreds of man-hours, coupled with numerous checks and an endless series of rigorous tests to boot. Each moving part of the plane also has more than enough backup options available to make sure flying a 747 is the safest experience ever. Nothing is left to chance here. The company with the largest fleet of 747s right now is Lufthansa, with 8 747-400s and 19 747-8s. The Air Force One, which is used to carry the U.S. president as well as other VIPs, only has a pair of 747-200Bs in its fleet. It has, however, placed an order for the newest 747-8 as well. Boeing and other airplane manufacturers keep it pushing the limits to ensure that their machines are beyond safe. However, the same can hardly be said for many auto manufacturers, who evidently have been cutting corners here on terra firma. It would therefore appear that when it comes to build quality airplane manufacturing, it's setting the gold standard that other manufacturers from all industries should aim for. And with that, we come to the end of today's video. We're sure you enjoyed it, so please do like the video as well, share it, and subscribe to Top Quick Week for more amazing content.